Now after selecting the orientation parameter, user need and the system definition, we can go for the detail losses parameter. So if we have to change any kind of a parameter in the detail loss, that we can change it over here. So the first loss is a thermal parameter. So due to the increase in the temperature, whatever the thermal loss factor will be there, so that we can just enter over here. So by default, it is a 20.0 watt per meter square Kelvin has been written over here. That is a constant loss factor UC. And here actually it is a formula of UC plus UV into wind velocity also. So due to the wind actually, so if we are placing the solar panel over the mounting structure, so if we are keeping on the free mounted modules with the air circulation, if a proper amount of the air is circulating around the solar panels, so what is the non-operational cell temperature is there actually, it is a 45 degree. If we have a semi-integrated with a air duct behind it, if we are taking the non-operational cell temperature is slightly increasing and the open circuit voltage, it will going to be affect on open circuit voltage, that is a 56 degree. If we are fully insulating our system and there is no places there for air circulation in the PV module, then the module temperature will going to be increase up to 68 degree. As good as the temperature is increasing, simultaneously it will going to be affect on the PV power that is generating at the end point, because it will going to be increase the open circuit voltage and simultaneously it will going to be affect on the other parameter also. So that is why we'll have to be just selected or make sure that wherever we are installing the PV panels, that where there should be the proper amount of air circulation will be available. So here the constant loss factor will going to be take it as an 20 watt per meter square Kelvin. Thereafter, once we have selected this particular parameter, we'll select the another parameter like the ohmic losses. So whenever we see these ohmic losses, we'll find the loss factor at the standard test condition. It is 1.50%, which is on an average value actually. So we just keep it as it is. Module quality and LID mismatch losses. Module quality losses, here is the module efficiency loss is there minus of 0.5. By default it has been given. If I want to change anything, that will going to be change it like this. Module mismatch losses factor has been given 2%. So these also we just keep it as it is. If we want to change, we can change it up to 1.5 to 2.5 in that particular range only. Then we have a light induced degradation due to the optical efficiency of an solar power plant. So here also we have selected the solar tilt angle in a such a way that there should be the minimum amount of the optical losses that will going to be happen. So we just keep it as an 0 over here. String voltage mismatch. So string voltage mismatch, we try to keep it as minimum as possible, because wherever we are keeping the solar panel, none of a solar panel should be having the any kind of the shading on any one of a solar panel. If a one string is having any one of a shading, automatically it will going to be hamper on the string voltage mismatch losses also. So that is why we try to keep it as an 0.0, but for the understanding we can take it as a 0.1%. And for the case also, if you have a higher shading parameter or frequently shading is happening on one of a solar panel, we can change it up to 0.5 also in that particular case. So here we'll keep it as a 0.1 as per the software has been suggested. Soiling parameter also we have to be mentioned. So let's say in any one of a situation where we are living, like in foreign countries, in European countries, in the winter season there are snowfall is happening, so the soiling losses they should be written as an 5% or 25%, 30% also they are giving us. But for this site where we are installing the solar power plant, so here the soiling losses are very minimum in that particular case. So if we require monthly basis, we can just define, or simply yearly loss factor we can select as an 2%. So on an average 2 to 3% soiling factor we can just take it over here. Then we have a IAM losses like the incident angle modifier. If we are keeping the solar panel tilt angle in the proper manner, these losses we can minimize as good as 0.05% also. And last is the spectral corrections. So this is related to the irradiance data that will going to be keep it as it is over here. So these are all parameters we have written. Once we have written this parameter, just click on the save button and just OK button, and we can just have this particular parameter.